Hey, it's Dr. Bear, and this lecture is about the Aggregate Expenditure Model. All right, so this is a part of Keynesian economic theory, and this particular model is, it's inspired by Keynes, but it was actually developed by an American economist named Paul Samuelson. Many contributions to both micro and macroeconomics. So this is where this model comes from. Okay, so again, the point of this model is to try to understand, right? Keynesian theory says it is changes in aggregate demand which lead to changes in the economy, which shape the economy, which lead to changes in GDP, which gives us the business cycle and is the key to smoothing out fluctuations in the business cycle. So a lot of the goal of Keynesian macroeconomic theory is again to smooth out the business cycle, to create a less volatile business cycle, a less volatile economy. All right, so changes in aggregate demand lead to changes in GDP, and as a secondary feature here, changes in the price level as well. Okay, but a lot of the focus on Keynesian theory is on GDP. All right, especially this model. This model is less good on changes in the price level. More on that later. Okay, so if it is changes in aggregate demand that lead to these real economic effects, then again we want to have a model for this. We want to know how much do changes in aggregate demand affect the total. All right, so let's say that we know that aggregate demand has got our different components, right? We've got C and I and G. Okay, so let's just write these down. Okay, let's say that C equals 100 plus 0.8 times DI. All right. Now, if you don't remember what these terms mean, go back and watch the other lecture about consumption, where all these terms are defined. Okay, investment. Now, rather than getting into the whole theory of investment and so on, let's just say that investment is 200. Okay, and all of these numbers are in billions of dollars. All right, so we've got consumption, we've got investment, and then government spending, our next component. Let's say that this is $200 billion. All right, and then finally, exports and imports. And let's just say that exports and imports are both zero. Okay, so the C and the I and the G, this part of it is the domestic part of the economy. Okay, the exports and imports have to do with international trade. That's the global part of the economy. Okay, so the domestic part, C, I, and G, we'll just limit our attention to that for now. Okay, so if we have this, right, then we can say, all right, we're going to add this all up to give us the aggregate demand. Okay, aggregate demand is another way of saying total spending. Now, in this model, this is called the Aggregate Expenditure Model. We rename it to call it AE, right? But just keep in mind, AE, AD, aggregate demand, aggregate expenditure, these are the same things, right? These are different ways of saying total spending, right? And that's what we're after with Keynesian economics. It is spending that drives economic growth, okay? So aggregate demand or aggregate expenditures, we're just going to add each one of these entries up, okay? So 100 plus 200 plus 200, and this gives us 500, okay? And then we have this other term here, this 0.8 DI, okay? And we're going to call that 0.8 Y, all right? So the thinking, how can we turn DI into Y, right? Well, the thing is, you might recall that total economic income, Y, is the disposable income, DI, plus taxes, okay? So we get disposable income by deducting taxes, right? If we add those back in, we have essentially, right, where do taxes go, right? They go to fund the government. Okay, so assuming a balanced budget and stuff, we're going to get into this a little bit later, but assuming that the budget is balanced and whatever, DI ends up becoming Y once we have added everything back in. That makes sense. Okay, so what we have here, AE equals 500 plus zero point 0.8 times Y. We have a linear expression, and this is called the aggregate expenditure function. All right, aggregate expenditure function, AE equals 500 plus 0.8 Y in this case, right? Okay, so we've got a linear function here, right? This is AE is the Y variable, right? Y, capital Y, is the X variable. And 500 represents the y-intercept, and 0.8 represents the slope, all right? And this is also equal to the MPC, or the marginal propensity to consume, all right? So we've got our function defined, and you're going to see problems like this on the test, on the exams, etc. And the main part here you're trying to do is to set it up, all right? So you've given some information about consumption, about the consumption function. Maybe they give you the marginal propensity to consume, or they give you the autonomous consumption, because remember, this term right here, 100, is the autonomous consumption. Okay, so this whole section really operates together as a piece. All right, you've gotten to the aggregate expenditure function, and then the next step we want to do is we want to graph that function. Okay, here's our graph. All right, we've got aggregate expenditure over here, AE, and down here we have Y. All right, so Y representing total economic income, and AE, of course, representing total spending. All right, now again, we are going to put on this graph a 45-degree line. Okay, so this line represents 45 degrees, and it's at 45 degrees because the same distance on our horizontal axis represents a certain amount of money, right? Again, this is in billions of dollars, and that same distance on the vertical axis is going to represent the same amount of money. Okay, so the 45-degree line represents all of the points where AE and Y are equal. Okay, that's the meaning of this line. All right. Now, this is a very important concept here, because where aggregate expenditure, AE, equals total income, this is our macroeconomic equilibrium condition. All right? So, macroeconomic equilibrium condition, let's think of it this way, right? Aggregate expenditure, remember what this means, the total spending. All right? And Y, what does this mean? Well, it's the total income, but think of it this way, okay? Think of it as, it's the total income, but think of it as production, okay? The total production in the economy, right? So what we're saying here is that what is produced in the economy must also be spent in that economy. And if that's not the case, that's a very temporary situation, right? Like we could have a situation where the income would be greater than the spending. Okay, so like this, right? What if aggregate expenditure is less than production? So imagine this was happening, right? Let's imagine that there was $2,000 billion worth of stuff that's produced, but only 1,800 billion of it actually is sold, is spent, right? Well, the difference here, 2,000 minus 1,800, would represent $200 billion worth of stuff that did not sell, right? And this is called inventories. Okay, so inventories would have increased, right? The goods that are sitting on shelves in warehouses, etc., right? That they will have increased, but that's not an equilibrium, right? Now we could have a situation where the inventories are also decreasing, right? If the spending is greater than what's produced, then all these items in the warehouses are flying off the shelves, and it's, but these things send a signal to produce more, all right? So our macroeconomic equilibrium condition is where aggregate expenditure equals total economic income. All right, very important. Okay, so the next thing we're going to do here is we're going to see, well, what is our actual aggregate expenditure function? All right. Now we're gonna graph that. Okay, so here we have our aggregate expenditure function, AE. All right, and here's what we know, right? We know that AE is equal to 500 plus zero point 0.8 times Y. All right, that's our aggregate expenditure function. Okay, so we've got two things when we're graphing this, right? We know that it's going to have an intercept at 500. It's going to have a point of intersection where it crosses the 45-degree line. This is important because this is our macroeconomic equilibrium. Okay, so to figure out where does this cross the 45-degree line, well, remember, for this to happen, our condition must be met. Okay, our condition is total spending equals total income. So where it crosses that 45-degree line, that condition is going to be met. If that condition is met, that means we can replace the word, like if AE equals Y, we can rewrite this expression like so, right? Y equals 500 plus 0.8 times Y, right? You can see why that's the case, right? AE is Y, well, we can put Y in there, right? So we got Y 500 plus 0.8 Y. Okay, so now we want to get the Y's on both sides, all right? So we can subtract 0.8 Y from both sides. All right, this one's going to drop out. Now, Y by itself is 1Y, all right? So 1Y minus 0.8Y gives us 0.2Y, all right? 0.2Y equals 500, okay? That's what we've come to. So 0.2Y, now we need to, again, solve for Y, all right? We can divide both sides by 0.2. So when we do this, we get Y equals 2,500. All right, so anything divided by 0.2 is going to be the same as multiplying it times 5. If you don't know that offhand, that's fine. Use a calculator. Okay, so this tells us that the point where it crosses the 45-degree line is going to be at 2,500, and that's the same, of course, on this axis. All right. Now, there's one additional piece of information that we need to fill in this picture. All right. What we need to know is what is the full employment level of output. All right. The full employment level of output. It's also known as the potential level of GDP. Okay. Now, you may recall from our section on employment and unemployment that what this means is that we're at the minimum possible level of unemployment. Okay, so this means that cyclical unemployment is 0. Okay, this is also sometimes in the literature, this is also known as the natural rate of unemployment. Okay, the minimum possible level. Let's say that we happen to know in this economy the full employment level of output is 4,000. Okay, again, all this is in billions of dollars. So our full employment output level, 4,000. Well, this tells us something, right? This tells us that where we are now, okay, our actual macroeconomic equilibrium, our actual GDP is less than our potential level, right? Our potential GDP is 4,000. We are going to be at 2,500. That gives us a gap, right? And the gap between our potential and our actual, in this case, it's known as a recessionary gap. All right, recessionary gap. And we can see, right, 4,000 minus 2,500, the size, the distance of this gap is going to be 1,500. All right, 1,500. So our goal would be to close that gap, right? To bring us to where we like to be is at that 4,000, right? That's where we want to be. So how do we get there? So our goal is to close this recessionary gap, all right? Now, to do that, we need to go back to our earlier material on how does a change in spending affect the entire economy, right? Now, remember, we talk about this with regard to the consumption function, okay? We know that there is a spending multiplier, okay? So remember, the spending multiplier is equal to 1 over 1 minus the MPC, same as 1 over the MPS. All right, now in our case, we know that the MPC here is 0.8, right? So the marginal propensity to consume, MPC, is always going to be the slope of our aggregate expenditure function. Okay, it's the slope of our consumption function. So we're going to put this in, right? 1 over 1 minus 0.8. We're going to get 1 over 0.2. We are going to get a spending multiplier of 5. Now you might recall this is a simplification. The multiplier is probably never that high, but it doesn't matter, right? For our purposes, we just want the simple multiplier, okay? So now what does this mean, right? What this means is for each new $1 of spending, all right? So, and when we say new $1, we mean the change in spending, okay? For a $1 spent, the result is going to be a $5 change in GDP, okay? Once it works its way through the economy, that spending becomes income to somebody else, which is then spent. It becomes income, that's spent, etc., right? That goes on potentially forever, all right? So whatever the new change in spending is, it's going to get multiplied through the economy. All right, so we are going to say the initial change in spending times this spending multiplier. All right, that's why it's called a multiplier, because we're going to be multiplying by it. Times that, that's going to give us the change in GDP, okay, delta GDP, and that's what we're looking for, right? This is we want, when the economy is in recession, we've got a recessionary gap, so the amount of the change that we need to see is 1,500, right? How do we know that? Well, that's the size of our recessionary gap, okay, 1,500. So we're working backwards from that. So we've calculated the multiplier. That's the next piece we're going to put in here. Okay, the multiplier is 5. All right. So our situation, what times 5 gives us 1,500. We can divide both sides by 5 in order to get this answer. Okay, so if this is like our x, right? So we got 5x equals 1,500. We're just going to divide both sides by 5. That drops out. 1,500 over 5 gives us 300. Okay, so that's what we're putting in here. All right, so our answer here is we need an initial change in spending of 300, all right, $1 billion. So that's a lot smaller than we thought, right? We thought, okay, if our recessionary gap is 1,500, we might be thinking, oh, well, we need $1,500 billion in new spending. But it turns out it's actually smaller than that, right? Because the new spending gets multiplied as it works its way through the economy. Okay, now how do we get spending to increase? We have said, look, there's consumption, there's investment, there's government spending, okay? So it could be any one of these, right? We could have a change in consumption, a delta C. We could have a change in investment, or we could have a change in government spending, okay? So any of these, right? Or maybe it's some combination, right? Could be any one of them, okay? So change in consumption, change in investment, change in government spending, okay? But here's the thing, all right? Consumption and investment these things are hard to change, right? These are the results of many millions of choices, right? Like the consumer spends the amount the consumer spends. There's millions of consumers out there, there's millions of households. We want them to spend more. That's hard to do. There's how do you get like you ever try and go to brunch with some people? Like 5 people show up at brunch. The number of phone calls and texts and emails and very difficult to get 5 people to do something at the same time. How about millions of consumers or millions of firms get them to invest? That's hard, especially if they don't think it's a good idea. Very, very hard to do. But government, that's centralized. That's in one place. Okay, yeah, it has to go through Congress and yada yada yada. But this is the easiest kind of spending to increase in the economy. Okay, so fiscal policy, right? Simply increasing government spending in response to a recessionary gap, right? If we change G, how much of an impact does this have? How much do we need to change G? Okay, so and we already have the answer, right? What we need here is we need to see an increase in G. Okay, that is a delta G, a positive delta G, and we already know how much it needs to be. Okay, $300 billion. All right. Now, if we do that, let's go back to our graph. If we change, let's add this in. Okay, so we're doing a delta G of $300 billion. Okay, so if we do that, we're going to get a new version of this. We are essentially shifting this up, adding 300 here. We are going to get now 800 plus 0.8 times y. Okay, our new intercept is at 800, and our new point of intersection here is going to be 4,000 and 4,000. Okay, so by shifting this, the vertical distance, again, that's the delta part. That's the change in government spending, although it could have been a change in anything, could have in any of the components of spending, right? But this is just the easiest one. We shift this curve up 300, and it takes us to our full employment output level, our potential level of GDP. All right. So this is how much of a change do we need to see in spending, and how might we go about it? All right. A very simple model of how total spending affects the economy. How much spending do we need? All right. So we can see from this. Look, if the government was to spend an extra $1 billion, look, wow, that sounds like a big number. Hey, good news, the government is spending $1 billion. Well, that's good, but that's not enough, right? We can tell from this model we need 300. Okay, it tells us exactly how far we need to go with this. Okay, so the change in government spending, the delta G needs to be 300. Okay, so this is an aspect of fiscal policy. All right, we are changing government spending in response to a recessionary gap. Now, there's another big, famous, well-known aspect of this fiscal policy as well, which is tax cuts. What if we were going to do that? Okay, let's explore what would that look like. What if we wanted to make this change in spending happen through tax cuts? Okay, so a tax cut represents a change in disposable income. All right, so if we said, hey, we're going to take that $300 billion and rather than spending it on new goods and services which the government purchases, no, we're not going to do that. We're just going to cut people's taxes by that same $300 billion, okay? And that means that people's incomes now go up by $300 billion. But here's the thing, okay? People's incomes go up by $300 billion, but they don't necessarily spend all that, right? Remember, the change in consumption, delta C, is equal to the marginal propensity to consume times that change in disposable income, okay? Delta C, MPC times delta DI, okay? So in other words, we know we've set from our setup, the marginal propensity to consume is 0.8. Okay, if we are then saying, well, the change in disposable income is 300, we're going to go 0.8 times 300, and that gives us 240. Okay, so the bottom line here is for the same size tax cut, we're getting less spending out of it, right? 240. Okay, we are going to work this through our same formula. All right, our initial change in spending, this time it's a delta C, times the spending multiplier. That's going to give us our change in GDP. Okay, so we are now using 240. Our multiplier is 5. Remember, that's 1 over the marginal, 1 over 1 minus the marginal propensity to consume. And 240 times 5 gives us 1,200, 1,200. Okay, so this is good. This is definitely a step in the right direction. But remember, in order to close that recessionary gap, what we need is 1,500. Okay, so 1,200, definitely very solid, right? Good effort. But it doesn't take us all the way, right? In order to do that, we would need to cut taxes more than that, right? We would need to cut taxes more. So in order to see exactly how much we would have to cut taxes, well, we have to work backwards again, right? We said, look, here's what we need, okay? Going back to this formula, delta C equals MPC times delta DI, right? So if we know that what we need to see at the end is 300, we know the marginal propensity to consume is 0.8, we just need to solve for the missing variable here, okay? So that delta DI is the thing that we don't know, all right? So 300 equals 0.8 times X. We're going to divide both sides by that 0.8. This gives us 375, all right? So what this is telling us, okay, so we got this answer. What this means is the 375 represents the tax cut that would be needed to bring the economy to full employment. Okay, full employment, potential GDP, or in other words, to close the recessionary gap. All right, to close the recessionary gap. So fiscal policy, right, these two elements, we could change G, or we could indirectly, right, by changing taxes, we can change consumption. Okay, dollar for dollar, the tax cut is not as an effective method of stimulating the economy. Okay, so what we're talking about right now is called fiscal stimulus. Right, fiscal stimulus, when government changes, what stimulates the economy through changes in fiscal policy. We have dealt with a situation where total spending, aggregate expenditure, we have seen total spending can be too low. All right, and in fact, Keynes says this is the major problem with capitalism. This is the reason we have recessions, is because total spending often is too low. Total spending falls, and then the economy enters a recession. Okay, so our next question is, can it be too high? Can total spending actually be too high? What would that look like? Can we use the aggregate expenditure model to show what that would look like? We can. Okay, so if it's too high, we get the opposite type of problem. Okay, so again, here's AE, here's Y. Here we have our 45-degree line, right? All the points of equality. Let's say it's like this, right? This is our aggregate expenditure function. Here's our equilibrium point. Okay, so we got this all set up. So the macroeconomic equilibrium, let's say the macroeconomic equilibrium occurs at 4,500. But here's the thing, all right? Our economy has a potential of 4,000. Okay, so Again, this represents the potential GDP, also known as full employment output level. Well, this is a different situation altogether, right? That the economy is, the spending is actually higher than the potential, okay? So here's the thing, right? You can't actually have this, right? The total amount that the economy is producing, right, at its potential, what this means what the economy is capable of producing at a maximum, okay? Capable of producing maximum. You can't have more spending than there is stuff, okay? Now, what you can have though is you can have more people show up who want to buy than there is stuff. That can happen, okay? So, and if that happens, then you tend to get rising prices, right? So, this situation where the equilibrium is to the right side of the full employment level, this creates something called an inflationary gap, okay? Inflationary gap. And again, we can see how large it is, right? The 4,500 minus the 4,000, this gives us 500, okay? There's an inflationary gap of 500. So the same ideas apply here, right? If it is a change in spending, that's what is needed, okay? So change in spending, and again, that's times the multiplier, okay? We got our spending multiplier. That's going to give us the change in GDP. In this case, we would actually want to bring it down, okay? Now, I'm just listing this I'm just listing this for completeness. Most of Keynesian economics is not really focused on this situation, right? Because Keynesian economics, it comes out of the 1930s, it comes out of the Great Depression. Keynesian economics is not really designed to deal with this situation where there's a lot of inflation. The model was modified and created to deal with that situation later, all right? But just for completeness, okay, we did recessionary gap and inflationary gap. Both of those things are theoretically possible in the economy. And by the way, this kind of thing, it's called the aggregate expenditure model, graph of aggregate expenditure. It has an alternate name, a kind of a nickname, which is the Keynesian Cross. Okay, the Keynesian Cross diagram, the Keynesian Cross, which I think is cool. It sounds like some kind of wrestling move. Put them in the Keynesian Cross. All right, so the key things you need to have here is you need to know, like, what is consumption, what is investment, what is government, exports and imports, if those are part of the model. Usually they're not, because we're just dealing with the introductory case here. Okay, and then we need to know what is this potential GDP or full employment, because that's very important, right? We need to add that to the graph so that we can see where are we, how close are we to the full employment output level. All right, that's my lecture. Thank you very much.